Let us understand what this fishy fisherman is doing in a lake. So basically, he has three stones hidden in his boat, and he is using those three stones to study buoyancy and the Archimedes principle, because he is in his heart a very dedicated physicist and he would like to do so. So let us say there are three stones here. Let us say I am drawing them in purple. So let us say this is stone 1, this is stone 2, and stone 3. Alright. So the fisherman had these three stones present along with him. He took these stones into a lake. So because of these stones, the water of the lake is going to get displaced, in the sense that the displaced water of the lake is supporting the weight of the stones, because they are now floating since they are in his wooden boat which is floating. So this is the initial case. In this initial case, let me write it down. In this initial case, so let us say case 1, when the stones are in the boat. Stones are in the boat. So in this particular case, how much amount of water is displaced? Now it is important for the student to focus over here. Here as much water is displaced as is needed to support the weight of the stones. So here volume of the water displaced volume of the water displaced will be such that its weight is equal to the weight of the stones. Will be such that its weight is equal to the weight of the stones. So let us say, let's try to find out that volume. If we just write a simple equation, then we'll get volume of water displaced in case 1. So I am writing that as V1 into density of water into G. Because of stones, this much amount of volume V1 is going to be displaced, and that is equal to the weight of stones. So that is volume of the stones, the net volume of the three stones combined all together, into density of the stones into G. So in case 1, we can see that the volume of water displaced in case 1 is going to be equal to Vs rho S upon rho W. Now naturally the density of the stones is much greater than the density of water. So the volume V1 is going to be much greater than the volume of the stones Vs. Okay. Now if this fishy fisherman throws the stones into the lake, now what happens? If this guy just decides to one day throw, or on the same day throw the stones in the lake, so the stones will sink to the bottom of the lake. Okay, the three stones are sinking and they have sunk to the bottom of the lake, let's say. Alright, so these are 1, 2 and 3 stones. Okay, they have sunk to the bottom of the lake. So now if any object is immersed inside a liquid, the volume of the liquid displaced is equal to the volume of the object itself, because now the object has immersed inside the liquid completely. So during flotation, weight of the liquid displaced is equal to weight of the floating object. When an object sinks, the volume of the liquid displaced is equal to the volume of the object. This is the difference that we need to understand. So let us say if we understand case 2 over here. In case 2, the stones are thrown. So stones have sunk. So once the stones have sunk, we use the principle that volume displaced in case 2 is going to be equal to the volume of the stones basically. So what is more? So volume displaced in case 1 is more, right? That means, let us say if I were to draw the diagram of this lake and this boat. Okay. So in case 1, what is happening? More volume is displaced in case 1. So that means, let us say the lake is also supported by a trench or a pit, you can say. Okay. So in case 1, since more volume is displaced in case 1, the level of water is going to be greater, or the height of water is going to be more in the upward direction. Now in case 2, what happens is lesser amount of volume is displaced. So in case 2, let us say green line represents the case 2, lesser amount of water will be displaced in case 2. So as we go from case 1 to case 2, meaning as the stones are thrown from inside the boat wherein they were floating and they are made to sink in case 2, wherein they are now at the bottom of the lake, the level of the water will go down, and hence there will be depression in the water level. Now in the same question, if it were to be analyzed, what about the level of the boat underwater? So let us say this is the level of water, and let us say what about the level of the boat underwater? So naturally in case 1, since the stones are going to be inside the boat in case 1, more amount of water needs to be displaced, so the boat has sunk more basically in order to displace that extra amount of liquid. Alright, so in case 1, the height of the boat underwater, let us say in case 1, is going to be more, and in case 2, when the stones are thrown outside, let us say in case 2, the stones are no longer inside the boat, then in that case the boat does not need to sink as much, because it does not now need to displace as much amount of liquid in order to sustain its own weight. Earlier it was sustaining the weight of the boat itself and its contents as well as the weight of the stone. So now in case 2, let us say if I write down this height, which is height of boat in case 2. So in case 1, height of boat in case 1 is going to be greater than height of boat in case 2. So this is the height of boat that, or that height of that part of the boat that is underwater. So as the stones are thrown, the level of the lake is decreasing. Okay, the level of the lake is decreasing, but the level of the sinking of the boat is getting elevated. So the boat is not sunk as much, alright, and the water is less displaced. So this is very easy to understand, extremely easy to understand if you intuitively understand this phenomena, that let us say if there is a container, this is a simple container in which water is kept. Now if I take an object, let us say any object, and if I just push this object with hand below, the water that was holding this amount of space will now get filled in this space. Alright, so earlier you can say that the stones were pushing this particular object. Let's say this is a hollow object, and let us say I am inserting my hand over here. Let's say we are inserting our hand over here and pushing this object below. Let us say it is a jar like this, something like this. Okay, so let us say it is a wooden jar that naturally floats. Now we are trying to push the wooden jar with force. So naturally this wooden jar, which its natural flotation limit was still here, now we are pushing the wooden jar, so the wooden jar will go further down below, right? So this is where the wooden jar will find itself. So since we have forcefully displaced the wooden jar, the water level will also get elevated. So earlier the stones were forcefully displacing the boat in the downward direction. Once we remove our pressure, then again the wooden jar will return back to its original level. Similarly, the boat will return back to its original level once the stones are thrown. Alright, so this is one interesting phenomena that is to be noted.